Hey, welcome back. This is our 10.6 notes, part 2. I'm starting with example 2, part B. This one's a longer problem, and honestly, this is the longest kind of a problem with radical equations that you're going to get. So if it makes you feel better, this is as hard as it's going to be, and if you can do this, you can do anything, okay? This one's so tricky because it has more than one radical, and stuff that isn't in the radical. So if I want to get a radical by itself, you can't just get one on each side and be okay. So let's talk about what we would need to do with this. So I think most of your all's first inclination is going to be, hey, can we just square the left side and be fine? About that. If you square the left side, you can't just square pieces and parts. You'd actually have to distribute, which would have a very, very messy middle term. So what I would recommend doing is just isolate one of your radicals so we can at least get that out of the square root. Okay? So I'm going to isolate the first one by subtracting the square root of x plus 1 on both sides, okay? And my cat loves you guys a lot. Alright, there we go. So if I subtract the square root of x plus 1, what it's going to look like is the square root of 2x plus 3 equals 1 minus the square root of x plus 1. Then, when I square both sides, I'll at least get rid of one of my radicals, which is helpful. Okay? Because this squaring and that square rooting is going to undo each other, and you're going to have the 2x plus 3 come out of the square root. So I'll have 2x plus 3 equals. Now, on the right side, when you square it, you have to actually square it. And what I mean by that is what this is actually 1 minus the square root of x plus 1 times 1 minus the square root of x plus 1, and we're going to need to distribute. I know that's more work, but it's mathematically what's actually happening. So we need to do things right. So when you distribute, you'll have 1 times 1, which is 1. You're going to have 1 times the negative square root of x plus 1, so that would be minus square root of x plus 1. You're going to have the negative square root of x plus 1 times 1, so that would be another minus the square root of x plus 1. And you're going to have the negative square root of x plus 1 times the negative square root of x plus 1. So a negative times a negative will give us a positive. And then you're actually going to have the square root of x plus 1 squared, which is going to undo each other, which is great. We'll have just plain old x plus 1 out of the radical after that. So then, you're going to say, that was a lot of work. But you know what's really cool? Is once we simplify this, we're only going to have 1 square root instead of having 2 like we did at the beginning. Okay? So what I'm going to try to do is, because these are like terms, we'll combine them together and have negative 2 square root of x plus 1, and then we'll only have 1 square root, which is helpful. And then I'm going to try to get that square root by itself. You guys ready? Okay. So what we're going to do to get that square root by itself is I'm going to subtract 1 from both sides. I'm going to subtract x from both sides, and subtract the other 1 from both sides, and simplify everything. Okay? So on the left side, I'll have 2x minus x, which is just x. I'm going to have 3 minus 1, which would be 2. Minus 1 again, which would be 1. So x plus 1. And on the right side, the 1 minus 1 cancels, x minus x cancels, 1 minus 1 cancels, and we talked about those being like terms because they're the same kind of square roots. So we'll have equals negative 2 square root of x plus 1. See, doesn't that look better already? And let's go ahead and get this square root by itself as well. So I'm going to divide both sides by negative 2. And so then I'll have negative 1/2 x minus a half equals the square root of x plus 1. And now that we have that square root by itself, we can square both sides and get rid of the radical. And then we won't have any more square roots, and that's always nice. So, let's see, the easy side is the right side, so the square root and the squaring is going to undo each other. So we're just going to have x plus 1 over there. The left side's a little bit more fun, partly because there's fractions, but partly because we're also going to have to do distributing. So when you square it, remember, you're doing it times itself. So you're doing negative 1/2 x minus a half times negative 1/2 x minus a half. So negative a half x times negative 1/2 x would be 1/4 x squared. We'll have negative a half x times negative a half, which would be a positive 1/4 x. We're going to have a negative a half times a negative a half, which would be another positive 1/4 x. And we're going to have a negative 1/2 times negative 1/2, which is another positive 1/4. Cool. So let's keep going. So I'm just going to keep going right up here. I've got some space. So simplifying all of that, what I have is 1/4 x squared plus, we've got like terms in the middle, 1/4 plus a 4th is 1/2 x, plus 1/4 equals x plus 1. Alrighty. So from here, what you might think is, can we get rid of all of the fractions? Yes. Yes, we can. If you want to get rid of fractions, all you've got to do is multiply both sides by the least common denominator. So with a 4 and a 2 and a 4, the LCD would be 4. Okay? So if you want to, you can go ahead and multiply both sides by 4, and at least get rid of all of our fractions. So 4 times a 4th would be 1, so we'll have x squared. 4 times a half would be 2x, and 4 times 1/4 would be 1. On the other side, we do need to multiply both sides by 4, even though they don't have fractions, it still matters. So we'll have 4 times x, which is 4x, plus 4 times 1, which is 4. Alright, after this point, we yet again are thinking, how do I solve this? And my clue is, I have an x squared. It's a quadratic, so we are solving by factoring, okay? So just like the last problem we did, to solve by factoring, we need to get everything on the same side first. So what I'm going to do is subtract 4x from both sides, and subtract 4 from both sides, so that it equals 0. Okay? So I'm going to have x squared. 2x minus 4x would be minus 2x. 1 minus 4 is negative 3. Equals 0. So now that I have everything on one side, which is helpful, you're ready to factor it. So I have a trinomial, which means I'm doing guess and check factoring, which is the reverse of FOILing. So I'm thinking, what times what? The first times the first should give me the first term. So what times what gives you x squared? It would be x times x. The last times the last should give you the last term. So what times what gives you negative 3? Well, with it being a negative, one of these is going to be positive, and one's going to be negative. And thankfully, 3 is prime. So your only options are 3 and 1, or 1 and 3. So then you're just trying to get to negative 2 from there. So I'm going to have a minus 3 and a plus 1. And just to double check, that would be negative 3x plus 1x, which is negative 2x. We factored it just fine. Okay? Then you set each factor equal to 0 and solve. So what that means is we're going to have x plus 1 equals 0, and we're going to have x minus 3 equals 0. Okay? If x plus 1 equals 0, I would subtract 1 from both sides, and x would be negative 1. If x minus 3 equals 0, I would need to add 3 to both sides, so x would be 3. And like all the other problems we've done today, you need to check your answers, especially in this case when you square both sides. You can absolutely create solutions that weren't there originally. So let's plug these into the original equation and just check to make sure they both work. Okay. So for x equals negative 1, I have the square root of 2x plus 3, so 2 times x, so 2 times negative 1 would be negative 2 plus 3. And then the next square root is x plus 1. So I've got the square root of x, which is negative 1 plus 1. And I'm going to see when I add those square roots together, do I actually... Okay. So let's see here. Negative 2 plus 3 is 1, so I've got the square root of 1. Negative 1 plus 1 is 0, so I have the square root of 0, and I'm going to see if that equals 1. The square root of 1 is 1. Square root of 0 is 0. And does 1 plus 0 equal 1? Yes, it does. So that's a solution for us for our equation, is x equals negative 1. Let's check the other one, because it might work and it might not work, but we need to know. So if I plug in 3, I'm going to have 2x plus 3 first, so 2 times 3 would be 6, and 6 plus 3 would be the first square root, plus the square root which says x plus 1. So for us, that'll be plus 1. And I'm going to see, does that equal 1? Okay. So first square root, we have 6 plus 3, which is 9. So I've got the square root of 9. Second square root, I have 3 plus 1, so I have the square root of 4. And I'm going to see if that equals 1. Square root of 9 is 3. Square root of 4 is 2. And 3 plus 2 is 5. And 5 is not the same as 1. So x equals 3 is not a solution for our equation. So we have one answer, which is x equals 1. You can certainly have two answers, just to let you guys know. You can also have no answer, because sometimes that works out that way as well. So it's very, very important with these that you check your answers. It's not optional. Okay? Alright, really quick, let's do example 3. This one will go faster, as you can tell by the small amount of space that I gave you. Okay? So what if we have something different than a square root? What if we have like a cube root or a fourth root or something like that? If you have a cube root, well, the opposite of cube rooting would be cubing. So if I've got the cube root of 2x plus 7 equals the cube root of 3x minus 2, to get rid of the cube root, I'm just going to raise it to the third power. And whatever you do to one side, of course, do to both sides. Okay? The great thing is that this is going to cancel out that cube root, and we're just going to have a 2x plus 7 on the left. And on the right, the cube root cubing are going to cancel out as well, and you're going to have 3x minus 2. So that works out really, really nicely. Okay? Then it's regular equation solving from here. It is a linear equation. It's not a quadratic. It's just plain old x's, which is great. So I'll just do normal stuff. We'll subtract 2x from both sides and add 2 to both sides. So 7 plus new is 9. And 3x minus 2x is just x. So I get x is 9. And that's my answer. And we should double check it. Okay? So if I check my work, I would have the cube root of 2 times 9, which is 18, plus 7 on that side. And on the right side, I'd have the cube root of 3 times x, so that'd be 3 times 9, which is 27, minus 2. And 18 plus 7 is 25, so I'll have the cube root of 25 on the left. Right, 27 minus 2 is also 25, so I'll have the cube root of 25 on the right. And guess what? The cube root of 25 is the same thing as the cube root of 25. It checks out. I know that it's irrational, it's not a perfect cube root. That's not the point. They're the same, and that's what you're looking for. So x equals 9 is a solution, and it works out wonderfully. Okay? Let's look at part B. We don't have a lot of space, but we're not going to need a lot of space. Alright, first thing I notice is that the radical is not by itself yet. All I've got to do to get it by itself is subtract 2 from both sides. So I've got the fourth root of 8z minus 3 equals, and if I subtract 2, it'll equal negative 2. And just like in example 1, when you get a negative, you should automatically have an alert that goes off, and you should stop and think, can that happen? Can I have a fourth root equal a negative number? No. No, we can't, because it's an even root. Now, if this was a cube root equal a negative number, could we do that? Absolutely. Okay, so if it's an odd root, it can equal a negative, but an even root never equals a negative number. So we can stop right here. It's no solution. Alright, last one is an application problem, and honestly, you guys can read pretty well. The main thing here is, here's your formula that we're using. N equals 1 over 2 pi square root of a over r. Okay? And part A says, can you solve that equation for r? Well, sure, why not? So let's see, we start out with n equals 1 over 2 pi square root of a over r. So I'm trying to get r by itself. First thing is, it's inside of a radical, and we're going to need to get it out of the radical at some point. But the radical is not by itself yet. So what I would do first is get the radical by itself and multiply both sides by 2 pi. So then we'll have 2 pi times n equals the square root of a over r. Then to get rid of the square root, you're going to square both sides. So that's going to look like 2 squared, which is 4, pi squared, which is pi squared, and n squared, which is n squared, and then the square root and the squaring undo each other. Then you need to get the r by itself, so I multiply both sides by r, And then you're going to divide by all of this. So 4 pi